Welcome to this overview of Lesson 1. I'm Kevin Keel, an OpenSciEd teacher and facilitator, and I'm excited to kick off this unit with you, Unit 8.2, where students are going to be investigating sound waves. And in this lesson, they're introduced to the anchor. I found it really engaging for my students. It really gets them to start thinking about sound, how it's produced, how it travels. So hopefully you find the same thing in your classroom. I'll give you a brief overview of the lesson and then some tips and tricks that I found helpful in my classroom. So in this lesson, students are introduced to the anchor, where they're going to see sound cause something to move. It's going to take 3 days for this lesson, about 10 minutes of prep on your part, mostly for a teacher demonstration that you're going to do. It does not require students to access or use their devices. And there's a video that you'll have to play right at the beginning of the lesson of a truck playing music that's causing some windows nearby to move. There's 3 different chunks or components to this lesson. To start off day 1, in parts 1 through 3, students are just observing sound causing something to move. In part 1, they'll observe it in the video that you're going to show. Part 2, they're just sharing out their observations from the video. And then in part 3, which I'll highlight more later, they're going to see this happen in the classroom. In your teacher demonstration, they're going to see sound causing some plastic wrap nearby a speaker to move. In chunk 2, which starts the end of day 1 and then carries on into day 2, they're going to start thinking through how sound can travel from a sound source to a sound receiver. And they're going to share their ideas with a model. And in part 4, they're going to make an initial model of how sound can make something move. In part 5, they're going to share their model. And in part 6, then you're going to start building your class consensus model. And again, I'll highlight more about part 6 later. And then finishing day 2 and then all of day 3, students are going to be sharing out related experiences that they've had with sound, questions they have at this point about sound, and that's going to drive the rest of the unit. So part 7, they're brainstorming related phenomena, like where else they've seen this happen. Part 8, they're going to start putting together questions they have at this point. Part 9, they're going to share their questions. Part 10, you're going to build the driving question board for this unit. Part 11, you're going to come up with ideas for investigations. So all of this chunk is just setting us up for the rest of the unit. On how do we figure out the uncertainties we have in our model at this point. So in lesson 1, what they're figuring out is that sound from a speaker can cause nearby objects to move. It has something to do with vibrating. They see the sound receivers vibrate, and in class they'll probably notice the speaker is vibrating in the teacher demonstration as well. And then they know somehow sound can travel from the sound source to the sound receiver, but there's a big question on how exactly that happens. Let me highlight just a few key moments. So in part 1, they're watching the video showing sound from a truck speaker causing windows to move. Part 2, they're sharing their observations. Part 3, you're going to try to recreate this in class. So you're going to set up a speaker producing sound towards some plastic wrap attached to a bowl. You'll need a speaker, amplifier, sound source. You'll have to connect all those so they play sound and play rather loudly. There's directions in the teacher's guide to walk you through it. There's also, if you're more of a video learner like I am, there's a video on our group's Facebook page that walks you through how to set this up. And then you're going to point the speaker at a piece of plastic wrap around a bowl, and you'll have to have them fairly close together. And just talk with your class about how is this setup that we have now in this demonstration, how is it similar to the setup that we saw in the video. And then have students make observations while the speaker is playing sound. In their T-chart, they're going to write down some noticings and some wonderings focused on these questions: what's happening to the speaker? What's happening to the plastic wrap? And then what patterns do we notice in how those things are moving? This then leads to parts 4, 5, and 6, where they start putting together their initial ideas of how this phenomena is happening in a model. There's a handout for this that you'll give students that'll ask them to just at first individually share their ideas on what's happening with the speaker, the window, and then the space between the speaker and window. And students at first, if yours are like mine, have a hard time knowing even how to model these things. Start with simple things like, well, what did you notice happened to the speaker? It was moving back and forth. All right, try to show that in your model. What did you notice happening with the window or the plastic wrap? Show that in your model. And then it's really interesting when they start thinking through the space between those things. Students, at least in my class, have often heard of sound waves. They know sound can travel, but they're not really sure how to show that. It's okay. At this point, there's not a right or wrong. Just prompt students to try to think through how these things might be happening, and then think through a way to show it in their model. And these individual models would be a great pre-assessment to collect at the end of day one. Just see where are students at in their understanding of sound waves and sound. And then when students are done modeling this individually, you're going to gather together in scientist circle, share out their ideas, and as a class, put together a class consensus model. And then parts 7, 8, 9, they're thinking through related phenomena, brainstorming questions. Part 10, then you're taking all these questions they have, both about the related phenomena and the anchor, and you're putting together your driving question board, where students are just sharing all the questions they have at this point. And as students are sharing, you can categorize them. Often, teachers I've seen just use the same model that they just put together as a class and post student questions. Are they related to the sound source, like the speaker? Are they related to the sound receiver, the window? Or are they questions about what's going on between the sound source and the receiver, the space between? So that's one good way to just categorize the questions. But then these questions in these categories or groups of questions, these will then drive the entire unit. These are the questions you'll be figuring out and investigating. And then at the end of lesson 10, you can pose the driving question for this entire unit: how can sound make something move? Next lesson, we're going to be then wondering if other sound makers show similar patterns. So students are going to be exploring musical instruments, look for patterns in what each one does when they're producing sound. See if it's similar to what they saw happen with the speaker in both the video and the demonstration. Let me share a few tips that I found along the way as I've taught this lesson in my class. First, when I'm introducing the anchor video of the truck producing sound, lots of times students have videos they've seen of sound causing things to move and break. If you have time, pull up those videos, watch them, run with it. Students love it. And there's some really cool videos out there of sound causing things to move or break. Next, the demonstration that you're setting up, it's a little tricky. You're going to have to practice it ahead of time, especially so that you set it up in a way that students can observe the plastic moving. First, you'll need an amplifier so that it's producing a loud enough sound. In fact, you might want to warn your neighbors. Things are going to be very loud in your classroom during that day. Next, you're going to need a song with a lot of bass. I typically just use the sound from the truck video. And then you'll need the plastic wrap to be like Goldilocks. It has to be just right. It has to be close, but not too close. it has to be, I found it helps if it's a certain tightness around the bowl. Like it can't be too tight or you won't be able to see it move. If it's too loose, it'll be hard to see. It has to be just right. And then last thing that's a little tricky in this lesson is you'll have to figure out how you're going to display your driving question board, especially if you have multiple classes going on at the same time. Some people do the big old chart paper. Some people do it digitally. I personally just do it digitally on Google Slide, and I have a different slide for each class. So that works for me, but you'll have to figure out what works best for your class. Words we encounter in this unit are sound source and sound receiver, and they can be introduced to the class when you're putting together your consensus model in part 6. And then there's quite a few posters. You're going to make a notice and wonder chart in part 2 when students are sharing out their observations from the truck video. In part 6, when you're making your initial class model, you're going to be making a poster for that that you're going to then save and refer to and revise later. And then other posters you're going to refer to in future lessons are the related phenomena, ideas for investigation, driving question board. So lots of posters, and a lot of them we'll be referring to later on in the unit. Well, that's it for lesson 1. I hope you and your students enjoy starting to think through sound, how it's produced, how it travels. In the next lesson, we'll investigate other sound sources and look for patterns in how they produce sounds. So I'll see you then.